Hello everyone, welcome to lesson 9-2, lines of best fit. In this lesson we will continue to learn how are patterns used when comparing two quantities, and we will use the expression line of best fit. In the previous lesson, lesson 9-1, we were working with scatter plots. So now we're going to determine how to draw a line with the information given somewhere in between the data or the information given in those scatter plots that best represents or best fits. And let's take a look here at the data and we will practice. This is simply an introduction. Please follow along. Cookies. The table shows the average annual cost of 1 pound of chocolate chip cookies. So since the year 2000, okay, this being the year 2000, then year 1, year 2, year 3, and so on, up to, I guess, the year 2009, we have an average cost of, that you can see it's increasing, not always increasing actually, it decreased here and so on. Okay, so it's scattered, the information. So we have years and average cost, our X and our Y. What year corresponds to 0 years since 2000? Well, if we're talking about the year 2000, and that's our starting point, that would be our year 0, correct? And then 9 years later, or 9 years since 2000, would be simply 2009, as we count it here from the year 2000 to 2009. If the data were displayed in a scatter plot, would the scatter plot show a positive, negative, or no association? Well, let's see here. I can see that we start at 259 and we end at 324. So, and we have some numbers that are definitely above 259. Actually, now that I look, everything is above 259. So if it's increasing, we can say there's a positive association, and because we see that the data appears to increase from left to right. Starting from 0, it would increase gradually. Okay? Question 3. Would a more reasonable prediction for the cost of cookies in 2015 be $3.25 or $4? Well, let's go back up here. As we see in 2009, we have $3.24. So would it only go up by 1 penny after 6 years, right? From 2009 to 2006? I highly doubt it. So it makes more sense if we would increase to the higher possibility. So I would say the data represent a positive association. $4 is a more reasonable prediction, seeing as it increased 54 cents in the 5 years prior to 2009. So if it went up by 54 cents, as you can see here, from $2.70 to $3.24, it increased by 54 cents in that time span. Why would it only increase by 1 cent in the next 5 years? It makes more sense that it would jump from this closer to the $4 mark. As you can see, it's important to use deductive reasoning, logic, and inference when working with data, scatter plots, and lines of best fit. So what is the line of best fit? When data are collected, the points graphed usually do not form a straight line, but may approximate a linear relationship. A line of best fit is a line that is very close to most of the data points. So essentially an average, okay, or a line that lies in between. And look at the example here quickly. You see, they made a scatter plot and they figured, you know what, if I drew a straight line right there, it would cover about half the points above the line and the other half the point below the line. On this side we have about 5 points, on this side we have about 4 points, and they fall on either side of the line, so that would be around the average. Let's see here. Construct a scatter plot using the data. Then draw and assess a line that seems to best represent the data. We have years, again, and the average cost of the cookies. Or, the cost of cookies. So let's see. We graph each of the points, then we draw a line that fits the data. About half of the points are above the line and half of the points are below the line. Judge the closeness of the data points to the line. Most of the points are close to the line, and you can see there. Okay, and we start actually on one of the points, and we draw straight through. Okay, so if we were to draw a line down here on these ones, all of these would be above the average, and that would be too low. So how can we represent that ourselves right here? So we're being asked now in example 2, or actually we're not being asked to do it, we're just going to analyze the data. Use the line of best fit to make a conjecture about the cost of cookies in 2013. Okay, in 2013, so if we're following this line, and here's the years, 2013, it looks like we're going out by every 2 years, we're right here. So right about this line, which looks to be about $3.35. Right? Do you see that? I can draw a straight line if it's easiest, where you see that the 13th year, or 2013, is right there. And if we follow it across, we see that it's at $3.35. Right? So extend the line so that you can estimate the y value for an x value of 2013 minus 2000 or 13. The y value for 13 is about 335. Yep, we can see that right there. We can predict that in 2013 we can predict that in 2013 a pound of chocolate chip cookies will cost $3.35, or about $3.35. Now this is the part where you get to try. Please make notes of what we see here. This is our first example for today's note. So make sure you have a title, Lesson 9-2, line of best fit, and this is your first example. If you need to pause now to copy all of this down for your notes, please do so. So we have a graph here, and the context we're being given is refer to the scatter plot about yearly points scored by a certain race car driver, years since 1999, and earned points. We start here at 0, at no years, and they already have about 500 points. And then we have scatter plot. Draw and assess a line that seems to best represent the data. And then B, use the line of best fit to make a conjecture about the points the driver will score in 2015. So 2015 being 15 here. Okay, if I had to draw a line, now I don't think this is one of the data points, or if it is, this is definitely an outlier right there. So I'm not going to account for that. So where I would draw my line is somewhere in here. I would start my line and match it, because that would leave me with 1, 2, 3, 4, 5 above, and 1, 2, 3, 4, 5 if I count the outlier below. And I would draw a line right about in here that looks like this, where it meets the 2 points and it leaves about half of the points above and half of the points below. Right? So that would be the line I would draw, and then use the line to best fit, the line of best fit to make a conjecture about the points the driver will score in 2015. So I go to 2015 and I follow the line up, and I see that I'm jumping up by 1,000 points each time, and it's crossing right in the middle of a 2, or just slightly above the half. So I could say 6,500, 6,600 or so. For A, I would write points are on both sides of the line of fit, and most points are not close. You can see they're not close. They're not following. They're not right along. I only have 2 points really on the line, but the rest are far from it. So it's an average of a big range, essentially. And then use the line to best fit to make a conjecture about 2015. But I would say, I would say about anywhere between, in 2015, like we're seeing here, I would say it follows about 6,500. Now you know that this is just a prediction. Your line might be a little bit different than mine. Your line might have maybe been down a little bit farther, where it maybe angles a little bit differently, and because you're trying to account for the distance for the bottom points. So maybe it would fall around here like that. And if that's the case, if your line falls a little bit farther down to account for the distance for these points, which you're not wrong for doing, then in 2015, we're looking more at around 5,500. So you can see how we would be off by about 1,000 points simply because it is a prediction. It is a prediction and it is an estimate. Okay, so now we get into the fun part. This is where we're actually going to use what we've learned before with equation of the line and slope-intercept form to write an equation. See, as you can see here, we're being given a scatter plot, and this one has a very linear association, positive linear association that's easy to draw a line for. The scatter plot shows the number of cellular service subscribers in the US since the year 1999 and the subscriber in the millions. Write an equation in slope-intercept form for the line of best fit that is drawn and interpret the slope and the y-intercept. So the y-intercept meaning where it begins, and the slope, which you guys know how to identify by finding the delta y over delta x. And you can see that here. Choose any 2 points on the line. They may or may not be data points. The line passes through points 3 and 150 and 9 and 275. Use these points to find the slope or rate of change of this line. You see here, we chose the 2 points, 3 and 150. So right here, 3 and 150. And we chose the points 9 and 275, 9 and 275, and drew a straight line through to show the slope. And then we did x2 minus x1 over x2 over x2 minus x1, which is delta y over delta x, change in y over change in x. We replaced our variables with our y2 minus our y1 over our x2 minus our x1. Found that it was 125 over 6, and when we simplify, we divide the top divided by the bottom, we get 20.083 over 1, obviously. And that's our slope right there. The slope is about 20.83. This means the number of cell phone subscribers increased by about 20.83 million people per year. And then they want us to write it in slope form intercept, right? Where we have to write y equals mx plus b. So that's called slope-intercept form. Here we go. The y-intercept is 87.5 because the line of fit crosses the y-axis at about the point 0.0 for x and 87.5 for y. This means there were about 87.5 million cell phone subscribers in 1999. If we use what we call slope-intercept form, okay, we have y equals mx plus b. We replace our y with, or our slope with 20.83 as we already figured, the m, plus our slope or y-intercept, which is 87.5 million. The equation for the line of best fit is y equals 20.83 x plus 87.5. Okay, so I'm sure you're noticing that everything is starting to come together. Here's another example. Use the equation to make a conjecture about the number of cellular subscribers in 2015. So now we're just going to use this equation to solve for any year where x is the year. And you can see here we're using the year 16 since we started counting in the year 1999, and where 2000 is the first year. You can see that back over here, right? So 2000, since 1989 being 0, then we have 2000, 2001, and so on. So that means that in the year 2016, right, or 16 years, the year 2015 would be 16 years after 1999. So in 2015, 16 years after, we would use the number 16 to replace our x, and we solve. And we have about 420.83 million cellular subscribers in 2015. So if you think you got it, give this a try. Pause the video, read through it, make notes, and try to solve it on your own. If you do, you will be in a much better shape for the next class. So let's go ahead and try this. If you pause the video and now you're just checking to see, great. If you haven't and you'd still like to try, Pause now. Okay, I hope you paused the video and now you're checking. Let's read through it. The scatter plot shows the graduation rate of high school students since year 1998, and we have the graduation rate in percentages. So right here, the 0 for the x value would be the year 1998, 1999, 2000, and so on. So this is the numbers of years after 1998. Write an equation in slope-intercept form for the line of best fit that is drawn and interpret the slope and the y-intercept. In order for us to do that, we have to identify slope, which is m, which is delta y over delta x, or change in y over change in x. And you know that that is y2 minus y1 over x2 minus x1. And now we need to choose 2 points. I'm going to choose point, let's see here, I'm going to choose 1 and 60. Okay, so those are going to be, that's going to be my first point, 160. And my other point, my other ordered pair, I will choose 4 and 65. You're probably wondering why I'm choosing those ones, but I try to choose the one where I have the crosshairs, where I see my y and my x intersect. So it's sitting right there. You see how the line? So it intersects both lines. It's a more exact number. So I would choose 4 and 65 for my other value. Okay, 4 and 65. And now I just replace my variables. So I will make these my 1s and these right here. So these will be my 1s and these will be my 2s. So my y2 will be 65, right? My y2 is 65 minus my y1, which is 60, as I mentioned, those are my 1s. And my x2 is 4 minus 1. Okay? That's what I meant by making these my 1s and these my 2s. This is my x1 and my y1. This is my x2 and my y2. And now when I solve, I get 65 minus 60 is 5, and 4 minus 1 is 3. So I have a slope of 5 over 3 where I rise 5 when I run 3. Or I can simply say 5 divided by 3 is 1.6 bar notation, or we can write it as 1.67 for simplicity. So I would write it as 1.67 so that it fits evenly with our slope-intercept form. So there you go. Make sure that you have your slope written. I'm going to write it up here to the side so that we know that that's what it is, 1.67. And I'm going to erase everything else. So I can use my equation now as y, to answer question C, y is equal to mx plus b. I write a plus b because I know there's a y-intercept. And I will replace those variables with y is equal to, as I mentioned, 1.67x, or actually if you really wanted to, you could write it as 3 over 2. Plus, now I need my y-intercept, and if I had to gauge what number that is right there, intercepting the y, I would say it is 59. That's my best estimate. So there is my slope-intercept form equation, and I can't forget my x in here, 167x, which gives me, I could say this is my percent change per year, right? That's what we figured out. That in my slope, 1.67, or I could say 5 over 3 is the percentage. So I would write something along the lines of, to answer question A, the graduating rate increased by 1.67% each year, with a starting point of 59% of high school students graduating in 1998. Now let's answer D. Use the equation to make a conjecture about the graduation rate in 2020. So if that's the case, 2020 would be 22 years after 1998. So my equation would look like this. Y is equal to 1.67 times 22, because it's 22 years later, plus 59, right? So when I do that, I get 95.74, and that's percent of graduates. And that's after multiplying 1.67 times 22 plus 59. So that gives me almost 96% at an increase of 1.67% per year. So there you have it, everyone. This would answer question D. Okay, and I answered, oh, that wasn't supposed to be A, this was supposed to be C. I thought it was just A and B. So that's it for today, everyone. I hope it helps, and I'll see you for the guided practice.